This is one in a series of Longhorn demos focused on different vertical industries, in this case, higher education. At the college and university level, your learning really is heavily influenced by the interactions you have with professors, TAs, and other students. Beyond the course content, your learning really comes from that collaboration and sharing. We're going to take a look at some of the ways that Longhorn helps developers and publishers promote those interactions by leveraging platform improvements that make it easier to provide things like shared workspaces and shared annotations and digital portfolios of learning materials. So from an architectural perspective, we'll see Avalon contributing to reading and visualizations. We'll see WinFS helping with the organization and annotation of documents, Indigo providing secure connectivity, and fundamentals in safely deploying interactive content. Let's start by logging in as Susan, who's a first-year physics student. We're going to see her open an application that leverages WinFS to organize both her personal and academic calendars, as well as all of her other e-learning content. So here in the application, you can see a combined view of calendars, documents, people that she interacts with. It's a way to manage her digital portfolio of material. Right now, she has a meeting scheduled with a classmate in astrodynamics. They're working on calculations to send a space probe to Saturn, and when she clicks on the meeting notice, she enters this shared collaboration space that the class uses, and Lionel is here in the foreground of her view because of their scheduled meeting. So here Avalon, Indigo, and WinFS are combined to provide a visualization of this shared space that includes things like instant messaging. So Lionel is asking Susan whether she's made any progress on the orbit calculations, and Susan responds with an IM saying that she could use some help. Lionel offers to explain this efficient technique he'd found called a home and transfer orbit. So he starts drawing with his tablet PC to show what that home and transfer orbit is. So he drags out the Earth, then Saturn, then the Sun, and he starts to explain that we're going to slingshot off the Earth's orbit to get to Saturn very efficiently. Even though Susan minimizes this illustration, it remains part of this shared space. There's just a huge opportunity in data visualization when you combine Avalon, WinFS, and Indigo. We'll come back to this and even visualize navigating through time, but for now, let's just look at the professor's highest ranked documents in his digital portfolio. So as we click on the professor, we see that one of his top rated items is a document on college physics. In this visualization example, the connections that you see are determined by links among people's digital portfolios. So when we click on this particular document, we're taken to McGraw-Hill's Sham's outline of college physics, where the professor has included an annotation on a particular chapter. So here WinFS is helping with the storage and sharing of annotations on documents, and Avalon is helping with the presentation of content that can be reflowed dynamically. So here when we expand the table of contents, we can easily navigate to the chapter that he referenced on the home and transfer orbit. Avalon's vector graphics and anti-aliasing and reflow capabilities also improve accessibility, since this page can be enlarged and rendered independent of screen size and resolution. So, for example, watch how everything on the page reflows intelligently as we're changing the font size. In addition, these equations aren't just static text. You can interact with the document by entering values into the equation. So here Susan's entering one value for the Earth's distance from the Sun and another value for Saturn's distance from the Sun. Using the values entered, the document even provides an explanatory animation of this particular home and transfer orbit between Earth and Saturn. So Avalon and fundamentals combine in Longhorn to help blur the distinction between document and application, making interactive scenarios like this easier to implement. As you hover over each variable in the equation, you see its value. In this case, the calculated value of t-transfer is 4.07 years, which is the theoretical duration of a trip from Earth to Saturn. This material is great, but Susan wants to return to the workspace to find sources that may help her validate her theoretical calculations with some empirical data. She figures that anyone that found this college physics book helpful over the past few semesters may also point to other great resources in their digital portfolios. So let's anchor on this book and use this calendar control at the top to kind of scuba dive back in time as we see all the people and documents passing by us as we navigate to prior semesters and then come back to the present. In this visualization, resources with the highest relevance float to the top. So Phil here seems to have consistently been ranked highly in relation to this book, and that makes sense since he's actually the TA for the class. So let's click on Phil to see the top ranked items in his digital portfolio. One of those items is this folder on background materials that's specific to the astrodynamics course. His folder includes an unpublished article that he's working on. The article requires a special 3D simulator that's deployed seamlessly with Click Once technology. In addition, since the article hasn't yet been published, it's protected by DRM. Only Phil's students can see it. Phil added an annotation that points out some great data files that he included in the article and that can be used with his new 3D simulator. Among those files on the right side of this article is the flight trajectory path for the Voyager. So by playing that file, we can visualize in 3D Voyager's flight path from Earth to Saturn. It's fun to see, but it also helps Susan validate her calculations with real-life observations. Being able to leverage Avalon 3D graphics and Media Foundation makes it more practical to include these kinds of interactive experiences in educational materials. So Susan sees that the actual trip that the Voyager made is pretty close to her theoretical calculated value. So in support of her project, she'd like to save this article and the simulation as part of her own digital portfolio. She can do that easily by leveraging WinFS to establish associations among documents and people. She'll just save this article, adding a few of her own keywords and granting rights to everyone in her shared workspace. So when Susan closes this article to return to the shared workspace, she now sees her folder of materials for the project that she and Lionel have been working on. Lionel congratulates Susan on her work, and now their relative ranking in the shared workspace goes up because everybody's starting to reference this new content that they've posted. So this demo and early work with McGraw-Hill hopefully sparks ideas about learning on Longhorn. We've seen how documents come alive with interactive equations and simulations via Avalon and fundamentals, how digital portfolios build in value as WinFS and annotations make it easier to organize and share information, and how collaboration is easier with secure connectivity of Indigo and great visualizations of Avalon. My name's Carter Maslin, and I want you to be a Longhorn evangelist, so don't hesitate to contact me. Have fun.